hopefully continuing. And we'll hopefully get this done. Why is this taking so long? God, okay. Guess it's working. Alright, I guess we gotta continue reading through this crap. I don't know. So in Total Recall, the remake or reboot, whatever, And the Kate Beckinsale's character slides across the floor and hits what's his name in the face. It's always funny. It's definitely better when I just listen to music than watch movies, but it's I don't know. Definitely get more work done if I don't have movies on. That's all right. My main factor right now is not watching movies. It's not working enough, period. This seems weird that like they did all this. Like, I don't know, it seems overly complicated. Yeah, I'm not saying it's not better, but this stuff is a core problem of a lot of things, is that any sort of automated thing, even if it's shitty, is just so much better than the manual way of doing things that people are more lenient on it being unnecessarily complicated. Like, which is for all software. That's why software is bad. It's easier to create bad software, and the bad software is still so much better than the other alternative manual ways that it's still a huge win. Yeah. I wonder if I could look up. I wonder if um, Google Cloud Automatic TLS certificate generation. I don't know what the thing. Surely they had. Do they have like I guess a question is, do they have a better? Yeah. Do they have a different API that's better? Probably not, because I generally think all of their APIs are, well, they're just unpleasant. Ugh. Already sort of zoned out. It's just so many buzzwords, wordy stuff in there. Oh, no, this is not really what I was looking for. Yeah. Okay. This is not what I was thinking about. Oh, I guess just when you I mean, you just like create certificates as a normal call, I think, in here, can't you? Well, where yeah, I know. Really, it's like certificate authority. Oh, service. So what I was on the other page. Okay. Um. Oh, is this? Um. Yeah, but these aren't like. Yeah. This is private only, I think. So, oh wait. got distracted thinking about um well, there was these humanoid robots on Total Recall that are seem very strong. And I started thinking about, oh yeah, you don't really like really all the robots should actually be like under 100 pounds, like 4 feet tall or whatever, for general purpose humanoids and something like that. And then um, uh, and so like um, it shouldn't have to be large. It should be so where any adult can probably overpower them if necessary. And anything that they have to do, they would use the same tools that a human would use. Um, so they aren't manually necessarily doing like heavy lifting and stuff like that or anything. So they could be very light. Like even the Tesla Optimus, I think, was 150 pounds or something. So this is a total sidetrack, but uh, size. There we go. 5 feet 8, so they should probably be 5 feet. And then, oh yeah, so 125. So like, yeah, they need to trim off at least a foot and get that down to 100 pounds or less. But that's still not bad. Um, I think that may have been actually that they said that that's like average adult or something is that or is less. Definitely not average American, that's for sure. So whatever. But anyway, so the point was actually this. So um, what would this actually be like? Like if you get one of these at home, do you just leave it plain? Like it comes from the factory or something? Um, which so everybody would just have the same looking robot or whatever. So how are you going to customize this? And so you could like start a whole store that's just like a Tesla Optimus clothing store. And it's basically the same sort of clothes that maybe other humans are wearing, but like everything's just one size that fits the Tesla Optimus or whatever. I don't know. That just seemed kind of funny that you could have a Tesla Optimus clothing store. Um, are there an alternative um, to the Acme protocol for automatically um, signing certificates. Certificates? I don't know. Whatever. Simple certificate enrollment protocol. Hmm. It would be interesting. So if you started like hosting these or any sites at mass scale, like you're doing a like sort of similar to a WordPress hosting, you did um hosting for whatever your app is with this built with this. And so then you could be like your own certificate authority even, and you could actually use that certificate authority thing as like a licensing model almost, where it's like, yeah, you can subscribe to our hosting service or whatever. Um, so basically just saying that your certificate, if you were doing it that way, could be sort of your way to make money is hosting and the or just even doing just certificates. Like if you're trying to figure out like, is this a paying person who I have to give support to or not, kind of thing. Anyway, I don't know. It's not really fleshed out idea at all. Um, oh, zero SSL is Austrian. So what is this other thing? Certificate, simple certificate enrollment protocol. Oh, uh, so I got off distracted with some thoughts. So um, I gotta remember to start just talking out loud. But the so uh, yeah. So I was thinking of what I was thinking about was like I started thinking about strings in general or text or whatever text string. Um, but it'd be interesting. So, but in like protocols or whatever, you got to send various words or whatever. There should just be like a here's a massive database, or here's a website. You can give us any, um, chunk of data up to, 255 or some other max size, um, 4096 bytes or something. Um, but whatever, some fixed chunk size of data that's up to that max, and it would just give you an ID number. So you just have this massive database of chunks that are given an ID number, and if you try to put in the same chunk, it would obviously give you back the same ID number that already existed. But just a giant enum for strings. Oh, I guess I was thinking about it because I was thinking, like, consider all these websites or APIs and stuff where they spit out these JSON things that are, you know, string keys and values and all these things. But even aside from that sort of ridiculous bloat that you could easily avoid, is that what if you just had a massive, just this big indexed of of you know different sets of string values, and so you just put your enums that are just in this easily accessible database on the internet. So like if you want to, so you just use this universal number, which I guess is similar to what maybe embeddings are. But so if you have like an email field, it's always, number 9 or whatever. If you have last name, it's field 42. And you just have this shared thing where, sort of shared intern strings or whatever enums that everybody can use. So you just have a universal number for these things. I mean, I may be describing exactly what embeddings are in neural networks or LLMs, but the it's more interesting if it's just just a web server out there that you can just go, give me what's the string for index 345 or whatever, and then you just cache them all, or maybe you just copy the entire database. It's just a shared database of, which really goes back to that other idea, but that I can't think of at the time. But it's just a huge compression dictionary ultimately. And so you just have this shared dictionary of all these chunks. And especially if you went from like, if you just had 64-bit integers for it or whatever, but you wouldn't do that. You would have you would have probably different numbered enums. So for, anyway, um, yeah, that's really when you get down to the very bottom. You just have this shared dictionary, compression dictionary. And prior things are like sort of for video or whatever, but it's how all compression basically is some sort of dictionary, whether built on the fly or shared in advance. So you need to just start sharing this dictionary, I guess. Uh, and it would probably work out pretty good if you were doing it in chunks where like they were sort of self-aware chunks, basically, of like, you know, if you, when you're inserting your chunk into the thing, you know that like this is sort of a packet boundary, or this is like the word boundaries and stuff like that. So you wouldn't like necessarily just do like, oh, I'm gonna always do 255 characters. So you just have like this thing and then gibberish or whatever for the rest of it. But I mean, because clearly also don't have a calculator. So like, I mean, So for I mean, a billion, say you had a billion, which, huh, billion times, say you just did crazy in 4096, 4K, which is a page size, I think, and well, it used to be there, or it's common page size, which obviously is just, that's a billion, that's 4 trillion, right? Ish. So, uh, 4 terabytes. So like the if you had full values and everything, so you just did, it's a flat chunk of memory. It has 4096-bit chunks, which really isn't that like a file system would work that way. But anyway, so if you had 4 terabytes and you just said it is these size things, um, you might do 4090, have one of these, maybe you store one less than this because you need something to somehow say maybe what the length of this thing is. Um, Although you probably should just do, have to have a zero at the end. In the thing on file or whatever. So, and I don't even think you really have to go that far. I'm gonna have to do this, aren't I? The real question almost is like, how fast would it be to look up something in here? Well, I mean, if you, the sort of, so the compression part of finding if any of these billion records, I think you should start with actually 255 or 256 for your 256 bytes for the string you're compressing to, would be pretty significant compression. So the question is, how many of these do you actually need? So the size of that number and the size of that number, what do they need to be? And that probably varies by obviously what the sort of randomness of the data is, I guess. But you could probably find good sizes for that for various things. But still, this is like, what is so, like, so if the 32-bit number would give you um, whatever, 4 megabytes, right? Basically. But I mean, this is in like the doable range. Like that's basically a gigabyte. So, but it's basically on the size of whatever your index is. So easily to 32-bit. And you might, and then there's probably something less than 64. Like you don't have to go all the way to 64 bits. Then the other question might be is like, should that be uh, just publicly accessible data as well? Which for the general case, the argument is yes, it should just be. Um, so you would could take a movie frame from a raw movie frame, and then you just do it into these chunks and put it all into this massive online database. But you can't really get out the movie unless you have the list of chunks. Um, but all of the data is obviously in there. The question is, how big would your database have to be? Uh, the other problem, though, is well, you could also start to do all of your data better or whatever. It's basically just a massive lookup table, obviously. Um, Shared dictionary, whatever. Uh-huh. No, 32 bits is 4 gigabytes, not megabytes, obviously. How do you do 2 to the whatever in here? X squared. How do you get the. Yeah. So this get a 32-bit integer, which I guess, IP addresses were 30-bit. I mean, that gives you a considerable size. And 64-bit goes to this crazy town. But even this time 256, well, yeah, gives whatever that is. What is that? Is that a terabyte? Hmm. Is that right? So that would be a terabyte for all of this. So that's obviously doable. But so then immediately you could just, this would just be a shared SQLite database that you could distribute. Um, or you can cache in a SQLite, but I mean, you could have just this 1 terabyte. I mean, it'd be bigger than I guess, but 1 terabyte SQLite thing. That's the way you can query that database and um, find the ID for it. But that would just be a read-only sort of version. Well, this is totally off track. But that wouldn't, I mean, that's definitely not hard to implement. The back end have to do the thing that chunks it, chunker. Well, you also have to have somewhere where you store your sort of file that goes with it, or the your index for the file that your chunk index. How would you search for this if somebody's already done it? Um, Web API. Oh, API for storing large amount of large enum with string or lookup table. Shared lookup table dictionary. uh, yeah. Yeah, and also, so what a SQLite. So it has um, um, 64-bit signed. Um, so 63 bits of actual value, I suppose. Um, hmm. Yeah. Like this should be a service, a dictionary service. Yeah, I mean, basically it's just a shared database lookup table. Like these humanoid robots in Total Recall are bulletproof. That doesn't seem like it should be a good idea. I do like their little box transport system. And really, you could do it with like smaller keys. So, like, you just say you're guaranteeing that, like, you could just, if all you need is the 8-bit keys, then that's fine. You don't, and they would always be consistent. Like, they would never not be whatever usable. You could also have private little stores if you wanted, but it would be super easy to just host your own. So I don't know that that would matter. It's really only valuable for the shared. But definitely the value has to be bigger than the key. And the bigger it can be, the more, huh, there's got to be a whole lot more on this. But there's probably not more to it, really. Hmm. I mean, more to that there's probably somebody's done a paper on it or something of something about it. Hmm. Yeah, I mean it is foreign keys. You would want some sort of controlled, like, what is it called? Um, is there just an online, I don't know, uh, neural network embeddings lookup table, API. What? No. Vector search? Is that what it is? Vector search? What the fuck is vector search? Oh. Yeah, okay. So, uh, hmm, uh, so I've just reinvented a vector database. Is that what the answer is going to be? Although it's for different reasons, kind of. So, I think you would just want to set the max size and then vary the uh, max item size and then figure out from there how many you can actually store in your storage space or within like a gigabyte or whatever you want it to be. And then there's so many things, like if you think about an image, like you could, you know, you're doing some closeness matches on an exact match. I really need to read the vector search is since I'm probably describing everything, but like when you're compressing with the dictionary, it's also that it could be like, okay, here's the actual dictionary value, and then also um, uh, it could be changes to the dictionary value to get to your actual value. So, but to do the compression, you would probably want to have a local copy of the database. And if something's not in the database, you look it up on, from the shared repository. So it's kind of like a page fault, effectively. I mean, the only real question is like, how big does the database need to be to like get to where basically you've stored everything in there? uh, and deciding on what boundaries to cut things. It is interesting to consider though, like, you know, the if you use a zero termination for the like value, you're only losing one character or one byte, whereas if you had to have over 255 bytes or whatever, 4096, you would have to have a larger key with wasted space unless you just go to 16-bit, which is probably what you would do. Have a 8, 16, 32, 64, whatever sizes for your index, um, which is really just IP addresses. If it goes max to 32 bits, same thing, which is also kind of interesting. Hmm. But you probably don't need to go all the way to 64 bits, which is interesting. So I'm gonna have to read this now. Other users. See, they're saying they're learning it, but where is it all stored? Like, I think that's part of the problem with all these neural network things is that, like, the copyright issue and more that the copyright issue is actually why they don't just outright memorize the stuff you're giving. Like, to me, a super intelligent should be able to just go, um, um, should just be able to regurgitate precisely, books or whatever. Like, it should just have all that information within it, like an oracle. But but copyright law definitely is preventing that now. I mean, they're barely skirting it for fair use, I guess. But like, if copyright law did not exist, um, you would definitely want to just have all these things in there. But I don't think, because I'm not really talking about a vector though. I think it's the deal why this is different. Because they're like dealing with combinations of the IDs, which, okay, that's also what I'm doing. But I guess in this case, the vector is what I was referring to as the index file. Yeah, I don't really want to like learn the embeddings in that way. Hmm. Yeah, this is a little different. We're just talking about text, or they don't seem to be talking about a combined database, or are they just a bag of bytes to a number? Also, I think they're not just, it's not just like, an integer. It's like, it's a vector of like floating point numbers, possibly. Got distracted by the movie briefly. Um, yeah. So anyway, um, this isn't quite what I'm talking about, I guess. Submit. Yeah. See, I don't know that this matters, but this doesn't feel like quite the same thing. Because, yeah, the clustering and stuff is, I'm just purely looking at it as a value, like a database lookup table. Hmm. What's DB? It really just needs to be a fucking SQLite database. Yeah, maybe you can't do the, well, I guess you'd have to find, if you did zero termination, it would be the last for storing your values. If it's just a flat binary chunk of file, disk, or whatever, direct. Um, but your like actual like index files or whatever would be variable sized, but they could equally be public. What? Okay. What? What the fuck is a data lake? Is that a thing? I guess what you could do though is, so if you, not this, but if you create this like, say, 8-bit service where you can have 255 bytes and um, the whatever 16-bit index or whatever. The point is, so you had this thing. Um, you could just let a lot of people have their own private one, and then you could figure out from there what the most common values are, and then from that figure out what the public database should be such that it could have, the most common values would be the smallest index number. So uh, that's kind of interesting, I guess. So you're just effectively you're building a massive compression table, shared compression table. And that probably is the better way to figure out what it should be, if it even matters. Like, because part of it would be, hey, you got, this, you've got 100-byte string. It doesn't matter if it's 32-bit or 8-bit to some degree. There's, I mean, it does, but you're getting a huge advantage without having to go that far if possible. Whatever. Could just do variable length integer for your values or whatever. Because all a table would be a massive string of integers. Seems like having it fixed size would be better. Oh. The thing about the shared table though too is like, so your field is email. Well, it's this number, and everybody can just use the same one if they want, which would be super handy because when you're doing syncing between services and stuff, they would all just have the same fields. Like that was the thing about all this stuff about JSON or XML or whatever, is that that's not the actual problem. You need to standardize the like key value keys or whatever, the IDs or whatever the names are, more than what what is wrapped in is less important. I don't even know what this is about. They've already lost me, clearly. Like they just move, they go into petabytes. So like yes, I mean it's clearly within reach, easily. One server probably, which arguably DNS is a distributed sort of shared database, exactly like I'm talking about. What is the max size of DNS response? I don't know that you really don't want to do DNS though, since that's already like um, what extension mechanism is supported. Without a DNS, the limit is 512. Oh yeah, that's what it should be. The maximum size of a packet without fragmenting is, which is like 15 something now, but maybe you could just do 512 is fair. This would be separate from DNS just because you just want to be way simpler than that. Hmm. 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 Yeah, it actually can go bigger. Hmm. Yeah, like what? My impression is externally that they're talking about that you're just storing large blobs, so it's less about What you would think also, like, I mean, what are, um, what do you call it? What are these like cloud storage people doing? Like, are they deduplicating stuff completely? Surely this has been done in like ZFS or some of these file systems, but or maybe not. I don't know. I mean, in most cases, on just a general purpose file system, you're probably not assuming you'd have a bunch of dupes. Like, why would you store the same file a bunch in a individual computer case? Hmm. I do, this might be it, but I don't like. Yeah. Oh no, I've got to no. I mean, those are all private anyway, but yeah, ID name. What? What? This has kind of gone off the rails. Yeah, note that it's dictionary, blah, 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 and not just, yeah, it's a fucking array. The thing, really, it shouldn't even be a SQLite database, mainly because it's unnecessary. Like, you're just looking for a direct sort of thing, possibly. I guess you can't really do the fixed. Oh well, on a main sort of system, you could do the fixed size thing of just a flat chunk of memory for the whole thing. But um, yeah, like how many, how many English or yeah, whatever. About 1 million for words in major dictionaries. Huh. So there's this many words in current use. 600,000. It's under a million, regardless. And you really, shit. I gotta go eat, I guess, and this has gotten way off track, but I'll need to plug in my laptop too. So